In this section, we're going to talk about measures of positions and outliers. If you remember from a previous lecture, we talked about the empirical rule. And the empirical rule was this bell-shaped distribution, and it was a way for us to talk about the percentage of our data falling in different areas of our distribution. So for example, if we wanted to talk about data that was within one standard deviation of the mean, that would contain 68% of the data that we're looking at. We move away from that, we can go one more standard deviation all the way out here to 2 standard deviations on either side, and I would add those percentages up and find somewhere around 95% of the data. So our empirical rule allows us to be able to kind of get in a sense for how much of the data is the percentage of the data and where it's falling. But what happens if I want to compare sets that are not, let's say, the same? Like maybe I want to compare apples to oranges, for example. So what we're going to talk about here is we want to say, and we're going to use the example of the SAT and the ACT tests. Most people are familiar with these tests. They're typical traditional tests colleges use for admission. But the idea of the SAT and the ACT is that they're both their score of both of them is going to be based on different values. So here you can see for my SAT score, that's going to be a score of 800. So if I took the math section of the SAT, it would score out of a total of 800 points. But for the ACT, that's going to be a total of somewhere around 35 or something like that. So you can see that we have different total values for each of these two scores or for each of these two tests. And so if I wanted to compare a score, how would I know what was better? Let me say that a different way. Let's say that I am in the admission department at a college and I have one slot available for a person to fill, but I have 2 people applying for that particular slot. One person took the SAT and the second person took the ACT. So which person scored better relative to their test that they took, the SAT and the ACT? And how will I know that? Well, that's where z-scores are going to come help us in this particular section. So the z-score is going to allow us to continue with this normal distribution shape. So we're going to assume that the shape stays the same. But notice that the center of my z-score is now going to be just 0. So I don't have an average like I do here for my SAT and ACT test scores. Instead, we're just going to zero it out. And then as I move away from that center, I'm going to be moving by 1 standard deviation each time. So as I move to the right of 0, I'm going to add 1 each time. And as I move to the left of 0, I'm going to subtract 1 each time. So these negative values that you see here for z-scores, those are, although I know that that my z-score is kind of like a position, the negative on that value tells me that I'm going to be below the average or below the mean, whereas a positive value is going to tell me that I'm going to be above the mean. So let's look at how we would calculate these z-scores. You see here that I have 2 different versions of calculating the z-scores, one for population and one for sample. They're basically the same formula. However, we know population is going to take mu and sigma, whereas sample is going to take mean, x bar, and standard deviation. So the idea here is that we take our value x, that's going to be our data point, subtract the mean, and divide by the standard deviation. Same concept over here for sample. You take your data point, subtract the mean, and divide by the standard deviation. Now for z-scores, the idea behind them is going to be unitless. So instead of me talking about, let's say, an SAT score versus an ACT score, I'm just not talking about a particular test. I'm not focusing on the test, if you will. Our z-score is going to standardize my position. It does this by keeping the shape of the distribution exactly the same. it zeroes out the center and it takes the spread and changes it to just one standard deviation as opposed to some specific standard deviation based on my data set.